So now we have Florian Sihler, who is from the University of Ulm, Germany, who will be talking to us about improving quality and reusability of R scripts using flowR.
Bioresearchers, or as I put it here more elegantly, by non-programmers. So people who have no computer science background and who are just getting into the area because they're domain-specific expert, they want to do their analysis on a social study they have done or a physical experiment they have conducted. And in general, when we look at these R scripts that we find in the real world and the artifacts they produce by doing their experiments, we find several things. First of all, there is a lack in sophisticated static analysis tools. And maybe you've never heard of the area of static analysis before, so I will be happy to tell you more about that in the following of my talk. Furthermore, and you may know that when you ever had the pleasure of working with R provides you with many powerful reflective capabilities that give you a lot of abilities to shoot yourself in the foot, and I will again give you a brief example of them later. And they again make it more difficult to have an automated system analyze the code for you and give you some tips or help you even with working with the program, even if you've never programmed before. And the language specification in and of itself is incomplete. Now, again, you might not care about the R language specification. You might have never heard of it or you have never read it. But in general, when you want to, as a software engineer, get at a language that you may have not that much experience in and you want to help R programmers in doing their research, doing their code, especially the fact that there are non-R programmers chosen some of these scripts, as I will get to later, it's very hard to get into the language and really understand what several of these features are supposed to do, or how something in R should behave, contrasting to how it does behave or how it's used in practice. And last but not least, and this is now the main issue that I want to tackle in my research as a PhD student, maybe a consequence of all of that, but a fact in the real world is that most of these published R scripts simply do not reproduce. So there are several studies, and depending whether you write R notebooks or you write your default R scripts, those numbers are slightly different, but ranging between 60 to 80% of the published peer-reviewed artifacts in the real world are either not non-executable at first, so they don't even run to completion, or they are not reproducible, given that they are at least executable. And so that's something that we want to tackle. So for this, we've analyzed a couple of files, and for the next presentation, or for the next part of the presentation, to be more specific, I want all of you to get into the mindset of a reviewer or a researcher who found an interesting publication and wants to reuse the figure or a statistical test that they've conducted there. And then you're confronted with an R script you see on the left over here. I'm sure no one of you is able to read this R script, but in the lower half, you find a citation if you want to check out the script in question yourself. And you just want to execute the script. As a reviewer, you may want to see whether they reproduce the results the authors claim in the paper. And as another researcher, you may want to plug in your own data set and just execute the script, reusing it for your own purposes. And the first thing you may notice is that this script, as I mentioned earlier, does not execute. For example, we're zooming in a little bit so you can at least try to follow what I'm telling you. You can see one of the issues right here, very, very at the top. Maybe you've spotted them already. They fail to replicate because, for example, they use hard-coded paths. And again, that might sound simple. Of course, you can adopt these paths on your own machine and link them to where the files are supposed to be. But when the script is very long and you don't either have much time or these paths are scattered throughout the program, intermixed with settings of working directories and concatenations, it's much more difficult than in this relatively ideal case to adapt them to your own case. And if there are several files with the same name, you yourself have to figure out which of these files you have to plug in and which path you have to now use given the artifact that the authors have published. To jump into another location, this is now a little bit more difficult and doesn't directly relate to executability, although this might also affect it negatively. They use pseudo-randomness without any setting of the seed. Okay. So in general, we have the problem that they are relying on pseudo-random number generation or anything like that. And even if you can get the script to execute, the results might differ on your machine. And here again, this is now one of the numbers I've mentioned to earlier. Again, there are some publications listed in the presentation, and you can check them out for yourself if you want to see how they got to those numbers and what they actually mean for the community. And so another problem is that when you're now trying to get the script to execute or even try to understand what they are doing and finding the figures that they are using or the statistical tests, they do way too much in a single script. Again, the script is very long and it's even one of the shorter ones given real-world R scripts. And they're doing multiple modeling operations, and they're creating various figures that might relate to each other, or they may not. They may build upon each other, or they may not. And now again, if some of these figures rely on a data set that's not shared by the authors for some reason, theoretically the whole script does not execute, and you yourself have to dig through the sources to find out what relates to each other and what actually is going on. And so in general, it's not just hard to comprehend, it's also hard to reuse or re-extract parts. If you just want a single figure and the whole script maybe takes multiple hours to complete or to compute, you may want your single figure and don't wait all the hours to get it to execute. And here's effectively the main challenge where we want to come in. The fact that R is hard to analyze, because when we now want to provide you with an automated solution to actually fix this problem, we're encountered by various features of R, for example, string-based evaluation, where we now have to check what all possible string values are at runtime. There are possibilities such as this one, and now this is a lot of code, so I assume on the important parts. You may have heard of the body or the substitute functions, and again, both of these are real examples we found in real world R scripts, published, peer-reviewed, everything, where they effectively use the body function to change the content of an existing function. So effectively what happens down here is with the body function, they change the first line, which reads bins is 5, to now equal bins is up bins. So given, for example, we set a new value for up bins here, they effectively change their existing code. And again, now, if you are a computer program that has to analyze this code and help you to understand what's actually going on, you have to be able to track it. And that gets very difficult very quickly. And this is what we are effectively trying to do. Again, now this is a slide I will skim over. There are not that many sophisticated analysis tools. So if you've heard of RStudio, for example, or the R language server, or if you've heard of linter, which is a very good first effort in that approach, which tries to tell you when you do something wrong or something that shouldn't be done in R, or maybe you've heard of CodeDepends, all of these lack in some way or another because none of them track these reflective features I've shown you earlier. None of them even support function calls and tracking the side effects of these function calls. And again, you can read through that at your own pace if you want to. I'll share the slide afterward. And so just to recompute, the R scripts fail to replicate in practice. They do too much. They are hard to analyze, and they are not well supported by existing tools. And just in the sense of better software, better research, there's certainly a lot to be done. And this is where we come in. I'm also wearing a shirt with the logo of the tool we are developing, and we get a little bit into the product pitch part now, but it's the tool that I'm developing with my PhD. We are developing flowR, or flowR, pronounce it however you like, where effectively the idea is to do all of this analysis, do all of the hard part, and then present you with features that you can actually use in your everyday work effectively, and that hopefully help. So for example, with flowR, when we again look at the models and the figures, you can look at a specific figure, and then flowR will reduce the program to just the parts which are relevant for this specific figure. So again, this is hard to read, and I'll share some QR codes for you to check that out for yourself. But now you get a program that just produces the specific figure. And even if the script as a whole might not be executable, several subparts may very well be. And the other way around, given a data set, we can show you which points of the data set are influenced by these things. And in average, doing those operations, they are called program slicing from a software engineering perspective, but that might not be relevant to you. We achieve average reductions of 80 to 90% per real-world scripts. So to put that around, just taking a real-world R script, focusing on a single figure, we usually just need 10 to 20% of the overall script code to produce this specific figure. Again, showing you how entangled real-world scripts usually are and what kind of potential there is to optimize them. Again, I've planned to say much more and for a live demonstration, but to close it off, there is an extension that you can use right now, which provides you with a dependency analysis. So it's showing you files that are imported by your project, which are libraries which are used by the project, scripts which are sourced, data which is produced. So it shows you the file it writes. It also shows you the plots that are visualized and everything. It can do the aforementioned program slicing, so the reductions. And if you want to, you can check it out right now. Again, if you search for penguins, that's also a good sign that I'm involved in some way or another. And I've prepared some live demonstrations. I probably won't be able to show them now, so you may use the question round to see them. But in general, if you hit me up at the conference, I'm there for the full days. I will be happy to show them to you. Thank you very much.
Thank you very much, Florian. If you wanted to ask any questions, there is Slido, which is going to come up. There aren't any currently, but I love what you've done is really just described a lot of the problems with academic code. And something that I was interested in understanding is, who are you aiming to be using this tool?
You. So yes, the community effectively. So people who have some knack or some awareness of software engineering, or are even able to act as multiplicators. Because what I again didn't show you in the presentation, we can also detect dead code or unused code, variable definitions which are unused later in the program. We can trace paths, even if they are constructed in a more complicated fashion, and resolve them to all possible files they may relate to. So again, if you work with R, and you think it's useful, I'm just now ended the second year and starting the third year of my PhD. There's still a lot to do. We are funded for 5 years in Germany. So you're the community, and we ask you for feedback. So if you're interested in trying it out, I would be happy either to show you or to receive your feedback. There's also a feedback button in the extension if you're shy. That's anonymous.
So a related question, is flowR still in a test phase, or is it ready for in application?
Oh, it's ready for application. So we've also done correctness tests. So what we did is we used reword scripts, we sliced them, and we checked whether the output of the slice is identical, so that, for example, all of the outputs are preserved and the script really runs through and everything works. And we're currently at a correctness rate of 99.7%. And even if we're unable to do it correctly, we can tell you which parts of the program, either because they use some eval or they use some binary load where the binary is not available, which could do everything in R, where the problem actually written.
So I don't understand what the question is, because I don't use R, but does it work with tidyverses?
Yes, yes, it does. We're still not able to tackle 100% of tidyverses use of non-standard evaluation in R. It's a pleasure and a chore to work with it, but we're able to handle most of it, especially deployer and all of the dataset related operation. And Marketer, of course.
One more question then. How can we pair flowR with, say, documentation to help users navigate our scripts?
Hey, that's an interesting question. So you can use it to generate the documentation if you want to. So it can give you an overview that updates in real time. Again, you can check out the extension. We don't take long for the analysis. On average, we need roughly 600 milliseconds to take the script and get all of the results out and produce then as many slides as you want, usually in 5 milliseconds per slide. From there on out, we have not delved that much into automatically generating interactable documentation or something, but first and foremost, it can help you untangle these artifacts. So even if you, for example, you've written your script, there's a lot of explorative code in there, and you just want to keep the part of the figures that you're actually using in the paper, you can again pick all of the figures that you're interested in as liking point and create one cohesive script that is then organized at least a little bit better. And yeah.
Amazing, thank you.
So again, yeah.
Is there a Python version coming?
So my supervisor insists on that I focus for R for my PhD, but in general, all of the techniques we're doing are applicable for Python just as well. Underlying, if we're talking about the static analysis perspective, so analyzing the code without executing it, it has the same problems in getting it to analyze from the perspective. So it's again an interesting research avenue, and if you're interested in that as well, hit me up. I'm walking around the conference and ready to talk.
Thank you so much, Florian.
All right. Thank you all.